So let's see some other remaining cascaded things. This is a IHI SPB tank. This is a different type of tank. Uh, then but this is a prismatic. You can see so many supportings, web transfers type construction, and for light insulation and outside tank. And this is a moss type tank which is being installed on the ship. And this is on the side is a equatorial ring for the support, like we have for the supporting and connecting the skirt. Then you have this chokes. Sorry, you have a primary barrier, then you have primary insulation, then you have secondary barrier, then you have a secondary insulation. So technique, as you can see, these are the waffles. Waffles are for expansion and to allow for the expansion and contraction. Then we need to know that the boil off percentage allowance on practically ideally it should be 0, but practically 0.1 to 0.5% boil off is allowed, but it has to be kept a minimum. Then there are reliquefaction plant in which as per charter the amount of diesel usage is given, how much it is allowed. Then we have some type C tanks. So Technigas membrane which we saw, the details are given here. It has a primary barrier 1.2 mmss, then corrugated corrugation of waffles for expansion and construction, insulation laminated balsa wood panels between plywood layers, inner cold plywood layer forms a secondary barrier, and balsa wood plywood panels interconnected by PVC wedges. Then this is the type C, independent tank cylindrical pressure vessel. You can see again it's a cylinder with good thickness, and you have anti-floating chocks and supporting saddle longitudinal section. So this is a supporting saddle. It's from, you have anti-rotation. Here you have most anti-rotation chocks or key. Then we have on some ships having this LNG as a fuel. So this is a container ship and it has a LNG tank, and the engine is using LNG as a fuel. So this LNG from here is around 10 bars. It's going and it's going into this compressor. This is number 2 compressor, high pressure pump. So number 1 is the LNG tank, number 2 is the high pressure pump, and this high pressure pump converts this 10 bar LNG into 300 bar LNG. So it's a compressed LNG now, and from here it puts into number 3 vaporizer. Vaporizer is there, it passes it through the seawater and makes it vapor by heating. So because we need vapor to move the steam turbine, to move the gas turbine, so that will be used. And also there is some boil off always, so the boil off will go into the small compressor and then to this unit, and again it will be used to compress and used as a fuel. So there are some new ships which are which you see. You will find it's made as per IGF code. They are dual fuel engine ships. In some places like Rotterdam or Singapore, you'll find that this LNG bunker barges for giving the ships which need like this ship for LNG as a fuel. And tanks also 3.5 bar pressure also having. So type C is mostly for, as you can see, for pressurized vessel, it's very thick, but some LNG barges are having also. So LNG cannot be carried as pressurized because its critical temperature is -81, and after that it will not. Uh, you cannot reduce the pressure. If you increase the pressure, still it will not reduce. And -81 generally you cannot have. So whatever pressure you put in LNG, it will not convert into liquid basically. So compressed natural gas which we are carrying is compressed, but it's not liquid. Then so this is the fuel vaporizer. It's called MEG, Maggie engine. It's there on some ships, especially LNG ships. And some pressure vessels, last point is that the pressure vessels may not be having your high level alarm because it's on pressure only. So how you will check the level, no? So high level alarms may not be provided.